Welcome to the pre-calculus notes for chapter 2.5a, titled The Fundamental Theorem of Algebra, and also called Solving Quadratics with Imaginary Solutions. Go ahead and put your first and last name and what period you're in. So we're going to look at the first part called the Fundamental Theorem of Algebra. It's basically going to ask you how many zeros or solutions does the polynomial have in the complex number system. And it's always going to be based on the degree. And the degree is when it's in standard form, meaning the largest exponent comes first. So in this function right here, we have 5x to the fourth, and it's in standard form. So the largest exponent is 4. That means there's going to be 4 solutions or 4 zeros. Some of them are real, some of them are imaginary. Okay? For this one right here, the largest exponent, and it's already in standard form, is 5. That means there are going to be 5 zeros. Some of them are real, some of them are imaginary. Okay, so if we have a second degree polynomial, that means there's going to be 2 solutions. And so we take the square root of both sides. I'm going to simplify the factors of 75, which 25 is a perfect square, times 3. And there's also a negative sign, so I'm going to pull out a -1, which when you take the square root of -1, that's where this I comes from. The square root of 25 is 5, and the 3 stays inside. Where the 2 answers come from is that one of them is positive and one of them is negative. So that's how you have 2 solutions in this case. Okay. For this problem over here, we have an x squared. So this one's also going to have 2 solutions. So we start by isolating this x squared. So we're going to subtract 15 from both sides. Then we divide by 8 since it's being multiplied by 8. Then the inverse operation of squaring is square rooting. And then we can simplify this square root of -20 to the square root of 4, which is a perfect square, 5, which is prime, and -1. So the square root of -1 is the I, the square root of 4 is 2, and the 5 doesn't have a partner, so it stays inside. And our 2 answers are from the plus minus. All right. This looks like the largest exponent is x squared, but when you multiply x times x squared, you add the exponents, and that would be a 1 plus 3. That means that there's 3 solutions. This x right here is easy. It's just 0. So that's the first solution. This part over here, the x squared plus 16, you subtract 16, take the square root, and you get plus or minus 4i. There's the other 2. Okay. This equation right here, take the x plus 5, set it equal to 0, subtract the 5, and your first solution is real. It's x equals -5. This one, you subtract the 98. And when you take the square root, you're going to get the imaginary answers, 2 of them. When you simplify the -98 under the radical, you get 49, which is a perfect square. You also have a 2 and a -1. So the square root of -1 is the I. The square root of 49 is 7. And the square root of 2 stays under the radical. The plus minus gives you the 2 and the 3 answers. Okay? Now let's look at some complicated ones. All right, the blue one on the left, what do we got? And do I need to shrink it? Let me see. There we go. Okay, now you can see it a little better. All right, so now we've got this quadratic equation, and it's not easily factorable. So I'm going to use the quadratic formula on it. So our A is a 1, which is right there. Our B is 4, and our C is a 15. So we're just going to plug those 3 numbers into x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so the first step, I'm going to encourage you just to plug it in and wait until you get to the next step to simplify. So you take the opposite of 4, which is -4, plus or minus the square root of 4 squared, which is 16, minus 4 times 1, which is times 15, which is 60. All over 2 times 1, which is 2. We can only simplify under this radical so far. 16 minus 60 is negative 44. So 4 is a perfect square factor. That's going to pull out a 2 for us. The 11 is prime, so it's going to stay inside. The negative 1 is going to get you the I right here. And most of the time you'll stop right here, but if you have a number that's a factor of all three terms, you can reduce it. Like 2 goes into negative 4 negative 2 times, 2 goes into 2 once, and 2 goes into 2i once. So just reduce it. All right, and our last one. It's in standard form, so we get our A, our B, and our C, plug it into the quadratic formula, and then we simplify. The opposite of negative 7 is 7. Negative 7 squared is 49. 4 times 3 times 10 is minus 120. And 2 times 3 is 6. So under that radical, we're going to go 49 minus 120, which is negative 71. That's going to get us our I. And 71 is prime. So we don't have any factors that are going to come out. It's just going to all stand to the radical. And if we could reduce, we would reduce, but this one you can't. All right, thank you.